Hello everyone. As you see, the topic we have to study today is a basic data structure operations with example. In today's video, we simply discuss the basic data structure operations with their respective examples. So understanding the common operation across the data structure. So what are the common operations we have to perform on different data structures? So we are looking this one by one. So first of all, what is data structure? So as we know, data structures are methods of organizing and storing data for efficient access and modification. So data structure is one of the method for organizing and storing the data for efficient access and the modification of the data. So we know that there are different types of data structures we have to study. So these are the different data structures in a study. What are they? So we are looking one by one. First is a array data structure. Second is the linked list data structure. Third is a stack data structure. Fourth is a queue data structure. Fifth is a tree data structure, and the sixth data structure is a graph data structure. In that, array, linked list, stack and queue are the linear type of data structure, and tree and graph are the non-linear type of data structure. So in this video we are just looking which data structure uses which operations for performing on a data. So here first of all we see the array operations. On array data structure, which operation we can easily perform. So first operation is the insertion operation. Insertion operation is used for adding an element at a specific position in an array. If we want to add a new element in a array, that time the insertion operation is going to be used. Here the example, insert 10 at the position or index value 2. So here you see this is one of the, in this array data structure the elements are 5 and 15. So if we starting the index value from 1 and we have to insert a 10 element, so our data structures look like 5, 10 and 15. And at the position 2, if we start the indexing from 1, so we are putting the 10 value at the index value 2 by using insertion operation. The next operation that is we have to perform on a data structure is a deletion operation. It is used to remove an element from a specific position. If we want to remove an element from an array data structure at a specific position, that time we are using the deletion operation. So in this, the 5, 10 and 15 are the array elements, and we have to remove the 5 first element from the array. So the result we get is 10 and 15. So deletion operation is basically used for removing an element from a specific position. And the third but the most important operation of array data structure, that is traversal or traversing operation. It is used for accessing each element in the array sequentially. If we want to access array elements sequentially, that time we are performing the traversal or traversing operation. Traversing meaning is visiting the or accessing each elements in the array sequentially. So these three operation we are performing on an array: insertion, deletion, and traversal. So these three are basically used for the array data structure. The next, linked list data structure, and for this linked list data structure, which operations we have to use or we can use. First is a insertion, again for adding a node at the beginning, at the end, or at a specific position we are using insertion operation. As we know, insert 20 at the start of, so we know this is the second element, this is the 30, 40 are the already elements stored in a node, and we want to insert a 20 element. For that we are creating a node and adding the 20 value in that. After that, the deletion, next operation is a deletion operation we are performing on a linked list. So for removing a node from a list we are using deletion operation. As we know, here is the simple structure or example for the linked list: 20, 30 and 40. If we want to remove the node or the element 20, then the resulting node we get 30 linked with 40. The third and basic operation we can perform on a linked list data structure, that is traversal. For visiting each node in the list we are using this traversal data structure. Next, stack data structure, the stack operations. For so the working is same but the stack operations name are different. So stack operation is basically, one is a push operation, PUSH, and another is a pop operation, and third one is a peek operation. So one by one we see why this push operation is used. So add an element to the top of the stack. If we want to add a new element at the top of the stack, that time we are using the push element or push operation. For inserting a new element in a stack we are using push operation. For example, the push 5, if the stack is already 1 and 2, and if we want to add a new element, that is 5 in a stack, if we want to insert a new element in a stack, that time we are using the push operation. The next is a pop operation. Remove the top element from the stack. As we know, this is the structure, and if we want to remove one of the element for removing the element, this 5 is removed from the stack, we are using the pop operation. Basically, pop operation is used to remove the top element from the stack. Here is the example: 1, 2 and 5. If we remove the 5 from the stack contains the two values 1 and 2. And third one is the peek operation. Peek operation is used to view the top element without removing it. If we just want to see, this is the stack, and we just the top of element we have to see, that time the peek operation we can apply on a stack. So these are the stack operation which we use for stack data structure. First one is a push operation, another one is a pop operation, and the third is a peek operation. Queue operations. So for queue operation there are also different type of operations. First one is a in queue operation, next one is a dequeue operation, and front and rear. So in queue operation is used for add an element to the rear of the queue. If we want to add new element in a queue, that time in queue operation is used. Consider in queue 4 into 1 2 3. Already in a queue 1 2 3 element is in 1 2 3 elements are already there, and if we want to add a fourth element, this is the rear side, that time in queue operation is going to be used. DQ operation is used to remove an element from the front of the queue. If we want to remove the element from the queue, that time we are using the DQ operation. For example, a queue containing 1 2 3 elements, and if we want to remove the element 1, that time resulting elements we are getting in a queue is 2 and 3. Next operation, that is front and rear operation. For view the front or rear element of a queue, we are using the front and rear operation. So on a queue data structure, we are performing in queue operation, DQ operation, front and rear operation. The next is a tree operation. On tree data structure, which operations we can easily perform. So tree data structure is a non-linear type of data structure. So first of all, insertion operation we can perform. For add a node to the tree, maintaining its structure. For adding a node to the tree data structure, we are using the insertion operation. So by using insertion operation, for example, we can insert a 25 into a binary tree. And the next and most important operation on a tree data structure is a traversal operation. So the next is a traversal operation, which can be performed on a tree data structure. In that, in order, pre-order and post-order. So traversing can perform in a 3 orders: in order, pre-order and post-order. So in upcoming videos we will see the detailed tree traversal operations. Right now I am just giving you introduction part here. And the next data structure, that is graph data structure. On this graph data structure, which operation we can perform? So first one is a BFS, that is breadth first search. BFS explore the neighbors level by level. For example, start from a node A and visit all its neighbors. And after node A, there may be a node B, C. So step by step, all the neighbors can visit by BFS. And DFS is a depth first search operation, which can be performed on a graph. Explore as far as the possible along each branch. For example, it starts from a node A and explore the deeper before backtracking. So what is backtracking and what graph data structure is working? So in upcoming videos we see in detail. So here we see the different data structures and which data structure fundamentally perform the basic which operations. So array perform the insertion, deletion and the traversal operation. Linked list basically use the insertion, deletion and traversal operation. Stack data structure is use push, pop and peek operation. Queue data structure use the in queue, DQ and front rear operation. Tree data structure uses insertion and traversal operation. Graph data structure uses the BFS and DFS operations. So in today's lecture we see the basic data structure and their operations. Thank you.